So now question number 2 of paper 42 May June 2025. Two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. And it seems to be a question of the collision of particles. So let's begin with making a diagram for it. So they say there are two particles P and Q. And their masses are given to be 0.2 and 0.1 kg respectively. And now they are moving in a straight line. So let's also represent that with a straight line, their surface. On a smooth horizontal plane, P is projected towards Q with a speed of 5 meters per second. So that means the direction of P is this way, and it is projected with a speed of 5 meters per second. So initial speed of P is 5 meters per second. At the same instant, Q is projected away from P. Now this is also projected, but away from P. So that means the direction of both will be the same. And now what is the speed of it? With speed 2 meters per second. So initial speed U of Q is 2 meters per second. Okay. When P collides with Q, the particles coalesce. Find the kinetic energy lost during the collision. Okay, so the important thing is that they coalesce. So this is what we have shown before collision. We need to show the same diagram for after the collision also. But for that, I just need a little bit of rearrangement. Okay. And now they coalesce. So this is your particle P and this is your particle Q, and they are joined to make one whole particle now. And yeah, so now their masses obviously will stay the same, but their velocity is now one whole velocity with which they are going to move. It's not like velocity of P and velocity of Q. It will be now a combined velocity PQ because now they are coalesced. Now let's look for the working that we'll be doing. So as always, we will be applying the conservation of momentum. Conservation of momentum says that total momentum before the collision should be equals to total momentum after the collision. This is before and this is after. So let's take that M1. In this case, we took it to be MP. So MP UP plus MQ UQ is equals to MP VP. Okay, instead because they coalesce, so MP plus MQ and whole velocity V, that we may call it to be VPQ. Now, what we will be doing, we know the mass of P was 0.2. So 0.2 and its velocity was 5 plus 0.1 times 2. Now the thing is, mostly in these questions, the problem arises when we have to deal with the opposite directions, but here both the directions are same, so we don't need to take velocity positive and negative, both will be positive. As for the convention, we may take that this direction we took to be positive, so both are in the same direction, so both our velocities are positive. So this is your left hand side of your conservation of momentum thing. And now for the right hand side, 0.2 plus 0.1 times VPQ. So solving this all directly with a calculator is a very good way and time saving way to do it. And directly when you will solve it with the calculator, you will get your velocity to be equals to, you will be adding these two and then dividing it with 0.3, and you will end up having velocity of the coalesced particle PQ to be 4 meter per second. Okay, this is how we found first the velocity of the coalesced particle, and that we just found to be equals to be 4 meter per second. Now what we actually need to find is the loss in kinetic energy. So as we know, what does loss mean? Loss in kinetic energy means the initial kinetic energy was more and final is less. So we are going to do initial kinetic energy minus final. Okay, and that will be, initial was half. Initial kinetic energy will be the sum of the two kinetic energies of two individual particles, and that will give you, it is better if we just try and rearrange it in a single line. It seems more understandable. So it will be, initial kinetic energy is half mp up square plus half mq vq square uq square minus final is half m1 plus m2 and their coalesced velocity, like the one whole particle, vpq square. Okay, now substituting in the values will give you half 0.2 times 5 square plus half 0.1 times 2 square minus half, the sum of 2 is 0.1 plus 0.2, that gives you 0.3. And what is the coalesced velocity, coalesced particle velocity, and that is 4. So yeah, we will take that to be times 4 square. Okay, and adding this all up together with a calculator would be a better option, and that will give you final result of 0.3. The loss in kinetic energy will be 0.3. And if you obviously want to write the unit, that will be joules, 0.3 joules. So this is all about question number 2. I hope you get it.